Okay, so we're going to be solving exponential and logarithmic equations today, and we learned that you can switch back and forth from logarithmic form to exponential form. They're inverses of each other, so they undo each other, and you can switch back and forth. They're equal, they're just different forms. Now today you're going to understand the whole point of that and a little bit deeper, but it's really cool how we can go back and forth. So that's all we're going to be. We're going to be applying that knowledge today to actually solve exponential and logarithmic equations. So we're going to just start out with problem number 1 on your worksheet. Now notice that they started out doing the work for you, and the way that they're teaching it is not how I'm going to teach it, because there's a few different ways to teach it, and they want to, like, as you can see, they kind of they're teaching it like 3 different ways, and to me, if I teach you 3 different ways, it's going to be confusing. I'm just going to teach you one way, and then you'll know how to do it. Does that make sense? Because no offense, but I think that's why a lot of people in your guys' grade don't know how to factor, is your teachers taught you 10 different ways how to factor, and then you don't know one way to factor. Does that make sense? So I'm just saying, there's a million ways. I'm not saying you're all don't know how to factor. I'm saying the ones that don't, their teacher taught them like 5 different methods, and they're like, I don't know. They combine them all. So we're going to learn one way to solve well, kind of 2. Anyways, let's just do number 1. Okay, so we have 125 raised to the 2x is equal to 25, and we're asked to solve. So this just means solve for x. We're just solving for x. But notice my x is up in my exponent of my exponential. So we need to get it down. So what we're going to do, now what we could do is, many of you are feeling like, okay, we're going to take log to the base 25, right, to undo 25. Right? We could do that, or we could just go like this. So now that we're solving, if we were asked to rewrite this as an exponential, we couldn't do that. But this one, we're just asked to solve. So we're just going to take the log of both sides. So I'm going to take, this is one way of doing it. I'm going to take the log of this side, and I'm going to take the log of this side. And I like to do it in front, so I'm writing it down here. So I'm going to show all my work. So I have on the left, the log of 125 raised to the 2x is equal to log of 25. So I'm taking log to the base 10, right? If we just write log, that's base 10, but that's the one our calculator can calculate, correct, everybody? Okay, so that's why I just chose to do log. Because if you do it to one side and you do it to the other side, you didn't change the equation, you manipulated it a little bit. All right, and then we have to think back to properties of logs. So because of properties of logs, we learned if we have something in the exponent, we can grab it and fix it, right? By pulling it in front. So with properties of logs, the nice thing is we can grab this and pull it in front. Everybody remember properties of logs? Yes. Okay. So we have 2x times by the log of 125 is equal to the log of 25. If you have questions, please ask. Some of you don't ask, and then you're lost. Any questions up to here? Now keep in mind what we're trying to do. We're trying to solve for x. We're simply trying to get x by itself. Now what you need to understand is this is literally just 2 times by x times by log of 125. That's all that is. So if we're trying to get x by itself, we'll divide both sides by a 2, so that our 2 will divide out, and we'll divide both sides by log of 125. So I did this side, to see my log of 125 will divide out, my 2 will divide out, but I have to do that to both sides. So I'm dividing by 2 log of 125. So over on the left at this point, my 2's divide out, my log of 125 and log of 125 divide out. So x is by itself, right? We just solved for x. Now we'll just type it into our calculator. So we have x is equal to, I'm just going to write it, log of 25 divided by 2, log of 125. But here's the important thing. You've got to use parentheses with these in the correct place, or you'll get the wrong answer. Because our 2 was multiplied to our log of 125, right? And our 2 is multiplied on the bottom to our log of 125. So we've actually got to make sure that we use parentheses on this one, and I'll show you what I mean. So I'm going to pull up my calculator here. If I can find it. Okay. So we're typing in log of 25, close my parentheses, and then I'm going to divide by. Now I have to put this in parentheses. So I'm going to put a parentheses and do 2 log of 125. Close my parentheses, close them again. so that it will keep the 2 multiplied to the log of the 125. Does everybody get what I'm saying there?
Yeah.
Hit enter. So our decimal is 0.33333. Repeating, I'm going to change it to a fraction if you can. So I'm going to go math, enter, enter, so it will change it to a fraction. So the answer is 1/3.
Wait.
So so that was equal to 1/3. Now we could check our answers, you guys. We could check our answers. We'll plug that back into the very first original problem. So the very first original problem was 125 raised to the 2x is equal to 25. We just said that x is equal to 1/3. We solved. We're going to plug it in. So we're going to be doing plugging in for x 1/3. So we're going to have over here on the left 125 times by, now 2 times by 1/3 is just 2/3, right? So 125 raised to the 2/3, which is equal to 25. This better be a true statement. So somebody do in your calculator 125 raised to the 2/3 power is 25. So we get 25 is equal to 25. That's a true statement. So we know our answer is for sure correct. And we're going to want to check our answers today because we're going to have some crazy decimals. And like I said, even I would get a crazy decimal and I'm like, I don't know if that's right. And then I check it. I'm like, well, it was, so I did it right. But a lot of times people will just forget to put the parentheses when they're doing it on their calculator and they'll get it wrong. Okay, let's go on to the next one. I'm going to do yes.
So that's number 1, right?
Yeah, that was number 1.
Okay, so then will you explain me why you broke it up from so 125 and 5/3 or
This part?
no, on the paper.
No, I told you just ignore that because it's trying to, this was like a paper that was like, you can use this to teach your students, but I'm not teaching it that way because then you'll know 3 different ways and let's just learn the algebra. And that's my opinion, so yeah. Okay, and let's do another one. We're going to do number 2 together. So we have 2 to the 3x minus 3 is equal to 64 we're asked to solve. This is an exponential. It'll be really hard for us to solve this without getting rid of it. How do I say this? Sorry, bringing this 3x minus 3 out of the 3x minus 3 out of the, what is that called? Exponent. I've been thinking really hard today, as you can tell. Okay, so now we're going to take the log of both sides. So we'll take the log of both sides. So over here we have log of 2 raised to the 3x minus 3 is equal to log of 64. All right, so now we know properties of logs. We're going to grab our 3x minus 3. We're going to bring it down in front. So I have in front, and I'm going to write it in parentheses, 3x minus 3 times by log of 2 is equal to log of 64. So just a reminder, this is log to the base 10. All right, awesome. So now we're trying to solve for x piece by piece. We've got to do this correctly. There's a few different ways of doing this mathematically, but the easiest way will to be, we're just trying to get x alone piece by piece. So right now, I'm just going to divide by log of 2. So that on the left here, I have 3x minus 3, which is equal to log of 64 divided by log of 2. Questions up to here? We're just solving for x piece by piece, so it's going to test a lot of our algebra skills. Okay, so now from here, we're just going to piece by piece solve for x. A few different ways of doing it because you've got to do it in the correct order. We could actually simplify, and this is probably what we should do because I think most of you, in pre-calculus they'd want you to actually write it out, but I think most of you, it'll be scary to see you guys write this out. I don't know. I'm debating. Okay, so, I don't know. Let's just try it. I guess we'll try. Okay, so piece by piece we're trying to get x alone. What should I do next?
3.
Add 3 to both sides. So I've got to add 3 on the outside here, right? This is what makes me nervous. Okay, so we have 3x is equal to log of 64 divided by log of 2 plus 3. All right, so now piece by piece, once again, we're trying to solve for x. Any questions on that part? Okay, what's our last step?
Divide by 3.
Divide both sides by 3, right? Divide both sides by 3. So we have x is equal to all that stuff. So x is by itself. So I would just be typing it in your calculator as you go, kind of. You could do log of 64 divided by log of 2, hit enter, then you'll add 3, and then you'll divide by 3. You've got to do it in the right order, though. Do you understand that?
Yeah.
So I showed all my work here, but I would type it in the correct order. So what is log of 64 divided by log of 2?
It's 6.
So this becomes 6 if you type it in your calculator. So we have 6 plus 3 divided by 3. So we have x is equal to 9 divided by 3. So x is equal to 3. And then we can check our answers. Let's quickly do that. Questions on that?
I have a question.
Yeah.
Would it like be incorrect if you did log of 64 divided by log of 2 first, and then you did the 3x minus 3 equals?
No, that would be perfectly fine. So you would have, that's probably, that's what I was like, maybe I couldn't decide, and now I'm changing my mind. We should have probably just done that, because then we would have had a 6 right there, and that would have been a lot prettier than this. Yeah. Okay. So now I'm going to check it. So we have 2 to the 3x minus 3. That better be equal to 64. We found x was equal to 3. We're putting that in there. So we're going to have 2 to the 9 minus 3 is equal to 64. Are you all following me? So we have 2 to the 6 is equal to 64. 64 is equal to 64. Check. We did it right. Okay. Only one more example, then I'll let you work on quite a few of them. So let's just do one more. So we have 81 times by, 81 raised to the 3x is equal to 27. We're trying to solve for x. This is an exponential, so we need to pull x out of our exponent. So we're going to take the log of both sides. So we have log of 81 raised to the 3x is equal to log of 27. Now we know that properties of log states that if we have something raised in the exponent, we can grab it and pull it down in front. So we're going to have 3x times by log of 81 is equal to log of 27. Now we're trying to solve for x in this one piece by piece, so we're going to divide both sides by what? Somebody said it. Yeah, what did you say? Good. 3 log of 81. We're just trying to get x alone, so good. We'll divide by 3 log of 81 so that x will be by itself. Now remember, you got to put this into the calculator correctly. So we have x is equal to log of 27 divided by 3 log of 81. And make sure you throw those in parentheses when you type it into your calculator. So let's see if you get it right. X is equal to 0.25. And we could leave it, I'm actually not going to be picky. You can leave it as 0.25 or you can change it to 1/4. Whatever you feel comfortable, but you can just check it really easily. Because we're going to check it by putting it back into the original answer. But you should get used to being able to do 81 and then you'll do caret on your calculator 3 times by, and we're going to put in our answer. So you should get in the habit, because we're going to have much bigger decimals than this, so it would be a pain to type in the whole decimal. So do second answer, the second minus, so then it will say answer, like that, I think. So 3 times the answer that you got just barely is equal to 27, and then it will say, it'll calculate it for you.
I didn't even notice I was there.
Yeah.
That's smart.
Yeah, cool, huh? So we checked it. Okay, so do 4 through 6. 4 through 6. And then the other ones we're going to learn one other way to look at it. Okay, so I'm going to bring you back to me really quick for just a second. So you could do problems 7 through 9 algebraically, but I bet you'll find this really interesting. And many of you that aren't super good at algebra, you might like this better. So watch this way. We could simply use our calculators to solve these. We wouldn't even have to do anything besides plug it into our calculators. So since we bought these schmancy calculators, we might as well use them when we can. But I'm an algebra junkie, so I'm always going to choose to do it algebraically over anything. But I want to give this option for those that don't love algebra and they're like they want to use technology. So this is how you'll do it in your calculator, okay? So TI, everybody follow me. Pull up your TI. I think a lot of you will find this really cool though, and this would be really good to know for like an ACT or end of level. Okay, so I'm going to go to my y equals thing here so I can graph. Sorry, I just got to make sure. Okay, but if we are going to use if we're going to use this this part of our calculator to actually solve these, you're going to be dealing with the window. You know how we've had to deal with windows before? So we'll have to make sure we can kind of see our function, but it's not super bad. Okay, so let's do number 7 together on the calculator. So we have the function on number 7. We're trying to solve 3 raised to the 6x power is equal to 2,000. So what we're going to do is it's saying when does 3 raised to the 6x power equal 2,000? So we'll just put it into our calculator. So we're going to graph 3 raised to the, and I'm going to do 6x. And those of you that have TI 83s like this, you've got to put the 6 and the x in parentheses. So you've got to do 3 caret parentheses 6x closure parentheses. It won't graph it right otherwise. Okay, so then I'm going to get out and scroll down, and then we have a straight line at 2,000. So 2, 1, 2, 3, 2,000. So we're going to just look and we're going to graph these. They're 2 separate things here. We're going to graph them. Now I'm going to change my window. So you have to go to your window and change it so that we can see it. So think about our y-axis is up and down, right? We're going to have a straight line up at 2,000, right? So we have to we just got to change our y max to 2,000. Okay, so now you're just going to hit graph. So it's graphing it for you, and it's going to graph that straight line in a second. Oh, but let's not do 2,000. Well, that's fine. But we should do above 2,000 because right there's the line. I'm going to hurry and fix that. I'm going to go above 2,000 so that I can see the line better. So I'm going to do like 2,100, just so I have some extra room. Okay, so now we want to know where they're equal, where they intersect. That's what that means, right? You guys should really use these calculators more to your advantage. So we want to know where they're equal. So right there where they intersect. So you'll do second trace. So then you can go down to intersect. Where do they intersect? So second trace.
No, I'm not having the second one come up. It's only the line. The straight line. I don't know why they don't.
Okay, so I'm going to trace and where they intersect. So now notice up here it says first curve. So notice at the top it's telling you which curve it's on. Usually it will do it right. So just hit enter. So it's on our 3 raised to the 6x. Hit enter. It says second curve. So it is on our line. So I'm just going to hit enter. And then it's going to say, do you want me to guess? So say enter again. Just say yes. Hit enter. And we got 1.1531066. So when we do it algebraically, we'll get the same answer. So our answer is 1.531066. Did you get it?
My calculator hates me.
The only bad thing about using your graphing calculator is then if you wanted to check it, you would have to fully type in the decimal. Does that make sense? And it's actually, in your calculator, it might come off a little bit wrong. Your fraction, like when I checked this one, was off by it was like 2000.0001, and it was off because your calculator can only show so many decimal places, so there's actually more decimal places, but if we're not going to be that specific. So how many of you like graphing better? A few of you. How many of you like to do the algebra? I do too. I'm just an algebra junkie. Okay, so now you guys can do number 8 and 9 however you prefer.
I just really wish I knew how to take these squares away.
Next part. Okay. So now we're just going to get to a little bit more involved problems. Not the same thing though, same thing, but a little bit more involved. So when you see something like this, first of all, everything that we've done so far, the exponential has been isolated all by itself, right? We haven't had anything added to it. So notice on number 1 on the worksheet, we have 3 raised to the negative 4.9n plus 9 is equal to 98. So I'm going to do this algebraically. So it's very, very important that before you start taking the log of anything, you've got to isolate the exponential. So we have 3 raised to the negative 4.9n plus 9. So we need to subtract 9 first. That's super, super important. So we have 3 to the negative 4.9n is equal to, what is that? Yep, 89. And now is the exponential isolated?
Yes.
Now it looks exactly like the ones we just did. So we'll just take the log of both sides at this point. 89, thank you. So now we'll take the log of both sides, and then 5 properties of logs, we know we can pull that in front, which is nice because now it's not in the exponential. The variable we're trying to find is not in the exponential. So negative 4.9n log of 3 is equal to log of 89. And now piece by piece, we'll just solve for n just like we did in the other problem. So we're going to divide both sides by negative 4.9 and log of 3. Do you have any questions on why I did that? So n's by itself. I don't want to rewrite it again. Scribble it out, yeah.
What if you did it like the longer way, where instead of putting negative 4.9 under, you divided all that by negative 4.9?
Then you would just divide again by,
So like, cause like either way you do it, you get a different answer. Cause like on the front, the number 7, I did it both ways and I got either 1.9 or 1.9.
right, because this is the thing. This was connected to this because it was raised in the exponential, right? So if you take the negative 4.9 and divide it to the log of 89 without connecting it to the log of 3, you've changed the problem. Like it was up in the exponential of our 3, so it's connected to the log of 3. So you have to multiply those together first because of properties of logs. You're right. So it would be different answers, and that's why we do the parentheses, is because then we're also making sure that we don't divide by negative 4.9 and then divide by log of 3. Does that make sense?
Yeah.
Okay. So you'll have to put parentheses around that. So what is n?
N is negative 0.8338.
Negative 8 point.
Oh, sorry, it's 0.8138.
33823, and then we could check the answer. You would just go back to the original, but when you're checking this one, you've got to be careful because you've got to type it in 3 raised to the negative 4.9 times 5, and you'll do second answer, right? So that it will type in the full decimal. Then you've got to get out of the exponent and then do plus 9, and then you should get 98 is equal to 98. Okay? Any questions? If not, you'll do 2 through 5 right now. Yes.
So number 3, you have 5 plus 1. Do you just
Okay, on number 5, do you divide by 3? Alright.
Okay, so now we know how to solve exponential equations. We were solving for something that was in an exponent. So to bring it down, we took the log of both sides, and then because of properties of logs, we're able to grab it and pull it out in front. So it's awesome. So we're able to do that. Now we're going to learn how to do the other way. We're going to be taking logs and solving logarithmic equations, okay? Okay, so looking at number 6 on your worksheet, we're going to be looking at this one. So just like with exponentials, how I said you have to have the exponential completely isolated all by itself, nothing multiplied to it, nothing added to it. With our logs, we have to have it as one log on both sides of the equation before we can start doing anything, okay? So looking at number 6, we know our properties of logs, right? Now looking over here on the left, are they both log to the base 9? Yes, so we can combine these using properties of logs. We're going to rewrite it as one log. Hey, that back group, I cannot hear myself think and no one else can hear me teach, so listen. So we have log to the base 9 of 5x squared, and properties of logs say that when we subtract, we will do what? Divide. So divided by 5. Any questions on how I made that one log? Log to the base 9 of 5x squared, we are minusing the log to the base 9 of 5. When we subtract, we divide, so we'll write it like this. We have that is equal to log to the base 9 of 64. Now we're trying to solve for x, right? That's what we're doing in all these equations. We're solving for x. So it's entrapped in log. It's entrapped in log. So we're going to get rid of log. How do we undo log to the base 9? We take the base of 9. All right, so we take the base of 9. If we do the base of 9 on this side, though, we've got to do it over here. Okay, so if we take the log of base 9 if we take base 9 of this side, we've got to do it to this side. So now we know that base 9 undoes log to the base 9, And then over here on the right, we also had 9 undo log the base 9. So that leaves us with 5x squared divided by 5 will be equal to 64. Any questions? Now we're trying to solve for x piece by piece. So there's a few different ways of simplifying this. First of all, we could cross multiply, right? 64 by 5. Or we could just say 5 and 5 divide out. There's a few different ways, however you want to do it. So I see that 5 and 5 divides out, but we could cross multiply. So 5 divided by 5 becomes 1. So we have x squared is equal to 64. We're trying to solve for x. So what do we do now? Square root both sides. So we have x is equal to, and we don't forget that when we take the square root, there's going to be a positive root and negative root. So x is equal to plus and minus 8. Any questions on that one? So I just applied base 9 to both sides, and then it happened to undo both sides. Log. Was that pretty easy? Okay. So now you're going to do these problems. We're going to skip around a little bit here. So you're going to do 7, 9, 10, and 12. 11. Okay, I'm doing number 11. So we have log of the base 9 of x squared minus 7 minus log of the base 9 of 2 is equal to 1. So we got to be really careful with these ones because you'll see why in just a second. So first of all, I'm going to combine it. Before we can start doing anything, we've got to combine this into one log. So properties of log says this is going to become log of the base 9 of, well, x squared minus 7, and then we're minusing log of the base 9 of 2. So we're going to be dividing by 2. When we divide, we subtract, or when we subtract, we divide, right? Any questions on how I made this one log?
Don't you need to get rid of the log?
Right, but this is the first step before we can get rid of the log, is make it one log. So it's equal to 1, right? But first of all, I need to know that you understand how this came about.
Yeah.
Okay, so now we need to get rid of log to the base 9, right? So we took base 9 of both sides, just like in the other ones, but we just got to be careful. Yep, good. So Spencer saw that this is going to be 9 to the first power. So we're going to take base 9 of both sides. So base 9 and log of the base 9 divide out, and that leaves us with x squared minus 7 over 2 is equal to, now this is where people mess up. They forget that we have 9 to the first power, which is just 9. So I'm just showing you where it's coming from. So we have x squared minus 7 is equal, over 2 is equal to 9, and then I'm just solving for x piece by piece. So I'm going to cross multiply. So I want to get rid of my fraction of 2. I'm going to cross multiply. I'm going to multiply both sides by 2, but it divides out over here, right? So I have x squared minus 7 is equal to 9 times 2, which is 18, right? Is everybody following? And then we're going to add 7. So we have x squared is equal to 25. And then our last step is to take the square root of both sides. So I have x is equal to plus and minus 5. And that's our answer.
Wait.
Number 8.
What was that? Sorry?
Oh, yeah, square root. Got that.
Oh, and that's
Okay, do number 13. Okay, so far we've been dealing with exponentials and logs, and we know that an exponential can undo a log, and a log can undo an exponential. They're inverses of each other. Well, we have talked about the special exponential function. So now we're going to be seeing the special exponential function, y is equal to e to the x. But we did talk about how that is just an exponential function, right? Everybody?
Yes.
Okay. Well, the inverse of an exponential function is ln. So ln and e, they undo each other. So anytime we're solving with e, with base e, we're going to have to use ln, not log, but natural log, ln, to undo it. And anytime we're dealing with ln's, we have to use base e to undo it. These two are inverses of each other. So the properties of logs hold true for natural logs, and it's the same thing from here. So let's just do a few of these real quick. So looking at this one, now the rules are the same. You have to make sure so we're dealing with an exponential. E, negative 4 times e raised to the x minus 6. So we have to isolate the exponential part. So we're going to divide both sides by -4. Divide both sides by -4. I'm doing number 14 on your worksheet if you're wondering. Okay? So we're going to divide both sides by -4. So then over here I have e raised to the x minus 6 is equal to 21, and I'm just going to calculate it, so 21.425. Now, notice we're trying to solve for x, and it's stuck up here in our exponent. So like I said, though, you can apply the inverse, which is natural log. So we're not going to take the log of this, we're going to take the ln. So we're going to take the ln of this side. Well, if you do it to this side, you've got to do it to this side. So we're going to take the ln of both sides. So ln undoes e on this side, and that leaves us with x minus 6 is equal to, and on this side we have the ln, and you'll just put it into your calculator, 21.425. So just like a log, ln's work the same way. It's just if it's e, you have to use ln, natural log. And now our last step to get x alone is to add 6 to both sides. So add 6. So I have x is equal to that plus 6. So I'll just type it into my calculator, ln of 21.425 plus 6. And we get x is equal to 9.064558.464. And we could check our answer by plugging it back up in here. So you'll do -4 times by e, and the e button is on your calculator. Raise to the second answer minus 6, and you will get that. I've checked all of mine. All right, I'm going to do number 16 with you real quick, and then I'll let you work for a while. Okay, so number 16. We have e to the -8x minus 3 is equal to 46. Before we can undo e, we've got to get it by itself. We've got to isolate it. So I'm going to add 3 to both sides. So we have e to the -8x is equal to 49. And now it is isolated. Well, we're trying to solve for x. It's stuck in e, so we need to undo e. So we take the natural log of both sides. So then ln and e undo each other, and we have -8x is equal to the ln of 49. Then we'll divide both sides by -8. So I have x is equal to the ln of 49 divided by -8. X is equal to -0.486. Practice typing that in to make sure you get the same thing. And so it's longer than that. I'm going to stop right there. Is everybody okay with that? It's no different. It's just you guys, when you see e, you have to use the natural log. If it's any other base, if it's not base e, you'll just use log. Okay? So now you'll do 15, 17, and 18. You just, I don't know. Sorry. We're going to do a couple more real quick. So now, same thing though, it's nothing new, but now notice, this time we're going to be dealing with ln's and we're going to solve ln equations. So it's just like logs, properties of logs, same thing, and then to undo ln, we take the e. So quickly, I'm going to combine this into one ln. That's the most important thing, is you have one ln on both sides of the equation. So we know properties of ln, say we're going to rewrite this as ln of, I wish I wouldn't have chose this one, x plus 7 times by x, which is equal to ln of 60. Okay, so now from here, I need to undo ln, so I'm going to take the e of both sides. So ln and e, they divide out, so we have x plus 7 times by x is equal to 60. And now we would solve for x piece by piece, so we've got to double distribute. We'll have x squared plus 7x is equal to 60. This is a quadratic, so we'll get it set equal to 0. And then we'll do the quadratic formula or solve by factoring. I suggest factoring. I'm going to go on to my next example. Okay? You guys should be able to finish that one out. Okay, so I'm going to do this one. We have ln of -3x minus ln of 9 is equal to 3. Before we can undo ln, we've got to combine it into one ln. So properties of logs will be the same for ln. So we have ln of -3x, and then we'll be dividing by 9. Is anybody confused about that? So this is number 22, which is equal to 3. Now, to undo ln, we've got to take the e of both sides. Now this one you'll want to watch. So we'll take the e of both sides. So e undoes ln, so we have -3x divided by 9 is equal to e to the 3. Do not forget the e to the 3. Okay, so now we're just trying to get x alone piece by piece, and this one we're not gonna do as, we're just gonna leave the e to the 3. We're not gonna actually do that on our calculator, because we're gonna just kind of keep it exact. So I'm gonna multiply both sides by 9, so I have negative 3x is equal to 9e to the 3. Then I'm getting x alone, I'm gonna divide by negative 3. There was another way to do this, but that's just the way I chose. So really we have negative 3e to the 3.
Whoa.
And we'll leave our answer right there.
What
We
just
could,
happened?
if we did calculate that, it would be a decimal, but I want you to leave it your e's if, yeah.
Wait, what? I don't understand what happened.
Just algebraically, I would solve piece by piece. So I multiplied both sides by 9. So then I had 3x is equal to 9e to the 3.
Oh,
So then
okay.
I divided by negative
So
3.
you just skipped steps.
I did skip.
Okay,
You
I
don't
was
know.
so confused. I'm like, where did you get the white? What?
Yeah, sorry. I usually don't, but just where we're feeling really rushed. Okay, and then, I guess I'll just stop there, but I want you guys to do all of those problems, okay? And then you have an online
We
assignment.
have 1 minute time. Woohoo!